I'm Alice, and would it be possible to build a full-size house out of Lego? Is it strong enough?
Good. Hi Alice, I'm Stephen Beck and I work at the University of Sheffield, and I thought your question about whether you could build a full-size house from Lego is a really interesting one, because what engineers work with a lot is different materials and different sizes of things. And you know you can make a little house out of Lego. I'm sure you've done that yourself. But then, as you ask, when you want to make a big house, what are the problems? And what we have to do then is think about how Lego works and think about how houses work and how we'd move one onto the other. So when we look at materials and when we look at how they go together, we think of what their properties are. So if I make up a column of Lego like this, it's really strong and I can push as hard as I like on that, and I'm not going to do any, it's not going to go anywhere. So generally speaking, if we make the walls about the same thickness as a real house, it's about like that, then the walls themselves will be perfectly strong. So they're not going to go anywhere. But then we have some more problems, because even if we can build the walls, we're going to have openings for doors and windows, and also we're going to have openings for we're also going to have floors on them. And then we start thinking about some of the other properties that we need to stand up to. And we know that Lego's very strong if we push it, then we call that compression. We also know that if you make up a bit of Lego like this, we can pull it, and it's pretty strong. So it's strong that way. Unfortunately, what Lego isn't is strong that way. So that's what we call tension. So when you pull things apart, we call that tension. When you push them together, we call that compression. And we can see that Lego's really good in compression and really bad in tension. So that starts giving us some interesting things. So when we want to build walls, they're in compression and they're fine. But when we come and think about floors, even though we're stepping on them, they're still in tension, because if we bend this, we can see the top bit gets pulled apart and then it will break. So one of our problems is that if we want to make a floor up, Lego's really bad for that, because if we bend it, it will break. And also if we make up a bit like this, which has got lots of walls like that, it will also break, because the bits will just fall off it as we step on it. So what we have to do is think, how can we build a house out of stone with floors and ceilings and the like? And we can remember that people have actually been doing this for thousands of years. So if you look at old bridges which are made out of stone, they've got an arch in them, like that. So if we build our house with an arch, then what we have is all of the weight pushing down on it from the top, and it turns into, it's in compression, which, as we remember, is the way it's really strong. So if we build an arch, all the forces push downwards, it gets pushed together, it's all in compression, and it's really strong. So if we use that sort of construction, we can build something really strong out of bricks or stones, which will also fall apart if they're pulled apart in tension. And of course, because people built things out of stone, a lot of old cathedrals and mosques and the like have all got these arches on them, which are made in stones in compression. And there we have a picture of the ceiling of a building with columns to hold it up, and we've got these arches on the top here which the stones fit into. So once again, we can build them like that. The other thing which works in that same way is an igloo. So I've made up a sort of igloo here out of Lego, and once again, that's quite strong if you push down on it. So that's curved and all of the forces push down on them. So what we can say is that you can't build a house like the one I'm sitting in at the moment, the one you're in, which has got beams like that with ceiling, with floors on them. But if we make things curved, if we keep them in compression, if we think about how people built in stone, then we can build very large things, because we have to remember what the properties of our material are, and we know they're very good when you push them and very bad when you pull them. So we have to think about ways of constructing things where we're always pushing on them. Thank you very much.
Hi, I'm Iriane. Why can't cars run on water instead of petrol?
Good question, Iriane. Water itself is very stable, so we can't directly burn it the way we do with petrol. However, we could use some energy to break it up into hydrogen and oxygen. Then we can use hydrogen to power the car. What we need to consider next is how the whole process can be safe and can be environmentally friendly. So thank you for your question.
Hello, my name's Jack. I'm 6 years old. Can you make a car with a solar panel on top to make it move?
Hi Jack, my name's Dr. Andrew Garrard, and I work at the University of Sheffield as a mechanical engineer. And I've got a question here from you, which is, can you make a car with a solar panel on top to make it move? And this is a really great question because it gives me an opportunity to talk about energy, which is a topic that I really enjoy talking about. So I think the short answer to your question is that yes, you could put a solar panel on top of a car and make it move, but there's probably lots of reasons why you wouldn't want to do that. So there are kind of obvious ones, like if you want to drive at night time, the sun wouldn't reach the solar panel, and so you wouldn't be able to move, or if you're pointing the solar panel away from the sun because you've changed the direction of the car, or you drive under a tree and there's shade. So there's those practical reasons, but the more important one, I think, is that the amount of energy that is required to make a car move, the rate at which you need to put energy into the wheels to get it to move at a speed that you would kind of want to drive around town, you would need an absolutely giant solar panel, and that will kind of get in the way as you were trying to drive down roads and things. So I did some very approximate calculations, and I reckon in order to get a solar panel big enough to drive at a sort of slowish speed for town driving, you would need a solar panel that was about 100 square meters big. And that's probably about the same size as a classroom you would have in a school. So a very, very big one indeed, and it would mean that cars driving around with this massive sail on the top of a solar panel would cause lots of problems. So I don't think you can practically do it. But there is a way round, because engineers like to find solutions to problems. So the way that you could get around this problem is to not take the energy straight out of the solar panel and put it into the car, but to take the energy from the solar panel and put it in a battery. And that way you could have a small solar panel that charged the battery up. And then when it was full, you'd have enough energy to drive the car around. The sort of thinking that you would then arrive at is, well, if you need to charge a battery up from a solar panel, why would you need to have the solar panel on top of the car? You could leave your solar panel at home, charge the battery up, and then put the battery in the car. And that's exactly what people are thinking about doing when we switch from traditional fuels like petrol and diesel to electric vehicles. But the other thing that I thought was really interesting that I thought about when you asked the question was actually traditional fuels like petrol and diesel also work just like a battery, because millions of years ago the sun shone on the earth, plants grew up, they decomposed and stored that energy just like a battery stores energy, and now we dig it up and put it into cars as petrol and diesel. So in many ways, the way a battery works and the way traditional fossil fuels work is very similar in terms of the fact that it stores energy. But thank you very much for letting me talk to you about that. I hope that's answered your question.